The method that I showed you in the previous video for finding the greatest common divisor doesn't work too well when the numbers get bigger. So in this video, I will show you a new method that works better when the numbers get bigger. For an example, we're going to find the greatest common divisor of 75 and 315. Now the first step in this method is to find the prime factorization of both numbers. 75 is 3 times 25, and 25 is 5 times 5. So that means that 75 can be written as 3 times 5 squared. 315 ends in a 5. So that means that 315 is divisible by 5. And 5 goes into 315 63 times. 63, as we know, is 9 times 7. 9 is 3 times 3. So this means we can write 315 as 3 squared times 5 times 7. Now we can just look at these two prime factorizations and read off the answer. The greatest common divisor of 75 and 315 is 3 to the 1 times 5 to the 1, which is 15. And that's the answer. So how did I do that? So first what you do is you say what numbers are common to both prime factorizations and write those down. Well, let's see, 3 is common to both, 5 is common to both, but you wouldn't put 7 here. You wouldn't put 7 here because even though 7 is here, there's no 7 here. Okay, now what you do is you look at the powers. So we're going to determine what power goes right there above the 3. The way to determine that is you look at the powers of each of the 3's in each of the prime factorizations. So that's a 1, that's a 2. What's the smallest of 1 and 2? Aha, that's 1. So that's why we have a 1 there. In a similar way, we look at the powers of the 5's in each of the prime factorizations. So we look at the 2 there, we look at the 1 there. We say, what is smaller, 1 or 2? Aha, that's 1, so you put a 1 there. Oops. And so 3 times 5 is 15. That's the answer. Now I want to go into a little bit why this works, why this is the greatest of the common divisors. So first I want to establish that 15 is in fact a common divisor of both 75 and 315. So first let's look at 75. So we're going to do this math, 75 divided by 15. And remember, if we get some integer here, then that means that 15 divides 75. So in other words, that 15 is a divisor of 75. So now, writing out the prime factorization of 75, from above we know that's 3 times 5 squared. And 15 is 3 times 5. Now doing a little canceling, we see that doing this math, we get 5, which is in fact an integer. Similarly, let's look at 315 and 15. The prime factorization of 315 is 3 squared times 5 times 7, and the prime factorization of 15 is 3 times 5. So now doing the math here, we get some canceling there. We get 3 times 7 which is 21, which is an integer. So this establishes that 15 is a common divisor for both 75 and 315. Now the thing to keep in mind, the thing to notice here, is that when we do this math, the result that we get, the thing that we get right here and right here, both of them have to be an integer. It's not a common divisor if we get an integer here, but not here. It's also not a common divisor if we get an integer here, but not here. Right? It's got to be a common divisor, which means that we get an integer in both places. And in fact, we see that with 15, we do get a common divisor in both places. So now let's think, why must 15 be the greatest of all common divisors? Why can't there be a common divisor that's bigger than 15? And so let's just play around with this a little bit and see why 15 is the biggest we can get to be the biggest that we can get where it's a common divisor. The biggest number that we can use that is the biggest divisor that gives us integer here and integer here. All right, so I want to talk about 3 different possible situations. The first is the one we talked about at the beginning. Remember I said you can't put a 7 here? Well, let's just say that we did. Let's just say that we did for the sake of argument. Well, that would be 3 times 5 times 7, that's 105. So we'd have 105 here, 105 here. 105's prime factorization we can see right here. That's 3 times 5 times 7, 3 times 5 times 7. And now doing some canceling on the bottom first, you see we get 3, which is an integer. So 105 is a divisor of 315. But now look at the problem. In the with 75, right? We get 5 over 7, which is not an integer. So 105, even though it is a divisor of 315, it's not a divisor of 75, so therefore it's not a common divisor. All right, so that's why we can't put the 7 there. Now let's say, okay, remember that we said we looked at this and this, and we said, what's the smaller one? Well, what would happen if we took the bigger one? Let's see, that would be 9 times 5, or 45. So we'd have 45, 45, 3 squared times 5, 3 squared times 5. And now let's do some canceling. So let's see. Looking at the bottom again, right? Cancel, 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 cancel. And we get 7, which is an integer. So that is to say that 45 is a divisor of 315. But 45 is not a divisor of 75. We can see that here. Let's see, 5 goes into there, 3 goes into there, and we get 5/3, which is not an integer. And notice that 3 squared times 5, right? This is bigger than 3 times 5. So here we got a little bigger, but it didn't work. Same thing with the 7. We put the 7 on the end, 3 times 5 times 7. That's bigger than 3 times 5, but it didn't work. All right, let's try and get bigger still. Let's find another way to get bigger. Well, let's see. What's another way to do it? Another way we could get bigger? Well, let's see. We could make the power on the 5 bigger, right? Remember this? We chose 1, right? Was the smaller. Well, what if we chose 2 because 2 is bigger? Now remember that 3 times 5 squared, this is going to be bigger than 3 times 5. And we're trying to think about why is 3 times 5 the biggest that we can have? Well, let's see. 3 times 5 squared, let's see, what's that? Oh, that's 75 itself. Okay, that's equal to 1, right? Because we do this canceling. And 1 is an integer. Now let's do this canceling here. And let's see, what do we get? 3 times 7 over 5. That's 21 over 5. Well, that's not an integer. So it doesn't work out if we make the power on the 5 bigger. And in a very similar way, we can't make the power on the 3 into a 2 and the power on the 5 into a 2. That's just not going to work either for similar reasons. So this shows you why the method that I gave, where we said, okay, what's the smallest? A 1 and a 1 is 15. That shows you why that method works to find the greatest common divisor.